Hello and welcome to this course on data analysis with Python. My name is Valentine and I'll be your instructor for this course. In this course, we are going to be going through the following agenda. We'll start off with just understanding the learning objectives of today. Then afterwards, we'll go through an overview section that will give us an idea of the concepts in relation to data analysis that we are going to be going through. So we'll talk about what are those concepts? Why do we apply those concepts, as well as when do we apply those concepts? After that section, we'll go through now some curated reading and quiz, and this should take us about 15 minutes. And the idea during this time is for you to be able to go through those concepts that we will have talked about during the first 10 minutes of the overview section. So that's during the what, why, and when section. So you will go through a curated reading, which we have prepared, which you can see on your screen. And this reading will contain some in-depth information about the concepts that we will have gone through in relation to data analysis. The idea is that you will go through this reading, and then later in those 15 minutes, you will go through some quiz that will just give you an idea of whether you have understood those concepts that you set out to work towards. After that, we'll go through now a practice session, which will entail now applying some of the concepts, actually most of the concepts that we will have gone through during the reading and quiz section, as well as the overview section. But now using the Python programming language, we have already curated a notebook that will contain just different concepts in relation to data analysis that will come in handy. So the idea for us will be to go through some of the examples, actually all the examples, and then work on the challenges that we will have provided. If you also want to practice a bit more further, again, we will have provided just a resource link for you to be able to have access to the resources that you're going to be able to go through. So this is the practice work that you can see on your screen. That's the practice notebook that will contain all the concepts that will pertain to data analysis that we'll go through. You work through the examples, and we will walk through the examples together, and then you go through the challenges. In order to ensure that you're also able to verify the solutions that you have provided for the challenges, we've also provided a solution notebook that contains solutions to the different challenges that you will get in the notebook. The idea is for you to be able to also verify some of the solutions that you will have come up with. After that, the next step, after you've gone through the practice work, the next step will be for you to undertake a project that we have provided. And the idea again is for you to put into practice the skills that you will have learned in a real life project. In this project, we've also provided a guiding notebook that guides you through the steps when it comes to just working on a project. So as you can see, this is a guiding notebook. And also we've provided a sample solution towards the very end. So generally, that is the approach that we are going to be using for this particular course. If you feel like you would want to go in depth in terms of the content that we have, you can also opt to become an Afterwork member, where we provide all the resources that we have mentioned for you for free, as well as other resources, tons of other resources in relation to becoming a data analyst or becoming a data scientist. But again, if you just want to see what happens in terms of when you're working with data analysis concepts or types of projects, we've also provided some sample notebook that you can always use to just follow through, that just walks you through the examples alone. But again, if you want to become an Afterwork member, feel free to do that. So getting started with our workshop for today, the objectives, the learning objectives of today are as follows. So the idea is for you by the end of the workshop to have been able to have achieved these learning outcomes. So be able to filter for records from a data set through the use of conditions, perform sorting in ascending or descending order while selecting records from a data set, perform ranking while selecting records in a data set, perform descriptive analysis using aggregate functions, create summary tables using group by and pivot table functions, as well as develop evidence-based conclusions and recommendations from any sort of analysis that you get to work on. So starting us off, what is data analysis? So generally, data analysis is the process of inspecting, cleaning, transforming, and modeling data with, of course, the goal of discovering useful information that you have that has been hidden within a data set. One of the languages that we're going to use, which is Python, helps us to be able to craft different types of solutions when it comes to data analysis. And it's because of several reasons. We use Python for the reason that it has a rich ecosystem. So when it comes to performing any sort of data analysis related task, you will find what are called libraries, which is just generally code that has been written to perform specific tasks. So you find libraries that would allow you to perform any sort of data analysis related work if you want. Ease of learning, Python is quite easy to learn when you're starting out. Well, that can be subjective, but just generally when it comes to even to delivering learning experiences, quite a number of learners tend to find Python much more easier as compared to other languages. There's community support, and you can use Python across different platforms. Doesn't matter whether it's Windows or Linux or Mac OS. It's always supported. And also when it comes to integration, if you have data analysis work you want to present possibly through the use of maybe a mobile application, you can be able to actually build out your solution, or you can build in your solution to even web applications, mobile applications, etc. So generally, data analysis comes in different forms. There are 3 or 4 types of data analysis. There's descriptive analysis, there's diagnostic analysis, predictive analysis, as well as prescriptive analysis. The first type of analysis, that is descriptive analysis, generally deals with historical data. When you look at historical data and you make conclusions based on what was observed, then in that regard, we tend to be performing descriptive analysis. So again, descriptive analysis data analysis looks at past data and tells us what has happened. And we might end up deciding to come up with some metrics based on just that type of analysis. Diagnostic analysis aims to determine why something happened. So if you wanted to determine why a particular event within a particular environment happened, I mean, why it rained, why students are failing, then you would perform this type of diagnostic, this type of data analysis. That's diagnostic analysis. There's predictive analysis, which just generally entails predicting what will likely happen. So you might want to write code that will predict whether it's going to rain tomorrow or not, whether students are going to pass a particular subject or not, or whether customers in a banking institution, whether they will likely to default or not. So predictive analysis comes in handy with that regard, and you might have heard of something like machine learning, the creation of such models, or that such kind of code that usually pertains to predictive analysis. The other type of analysis that you might get to come across would be prescriptive analysis, and this type of analysis combines information from all the previous 3 types of analysis in an effort to solve for a particular problem. So you might have a business problem, but that business problem would require that you perform descriptive analysis, diagnostic analysis, or predictive analysis. And with that regard, the kind of work that you're going to be doing is also providing recommendations. After doing all of that, you provide also recommendations in order to solve for the problem that you are working towards. So generally, the focus of this workshop will be leaned towards on the descriptive analysis end. So the types of deliverables that we are going to be creating will just be basically reports that analyze historical data, and you're able to provide solutions to various research problems and help organizations be able to make insights about whatever aspect of the business that they're going to be doing. Diagnostic predictive analysis as well as prescriptive analysis, those would normally be covered in a separate workshop. And sometimes something like predictive analysis can be covered through different multiple courses. You could cover possibly a course on introduction to machine learning, or even introduction to predictive analysis. You could also cover working on specific types of predictive analysis like regression or classification, or even Ensembler, which is just an advanced more type of analysis when it comes to prescriptive analysis. So generally our focus for today would be on the data analysis aspect, on how we can be able to just learn basically from data that we have collected or an organization has collected. Now, when it comes to again, descriptive analysis, there are different aspects of analysis that we can perform. We can decide to explore data. So we could decide to explore data. That means get a data set, read it or load it, then preview the first few records to understand the structure of the data set. We might also preview a sample, again, to also to have a fair understanding of the data set. We might also decide to even look for any missing values or liars, or even just study the distribution of a data set. By that, we mean how spread the points within a particular data set are. So that is something that we could do: data exploration. We could do data visualization, and we could also do some summary statistics. We could determine such statistics such as mean, median, mode, variance, in order to just, again, understand the data set really well. Now, our focus, again, for this workshop will primarily involve understanding the data that we are going to be working with. We could, and the end goal could actually end up being for the purpose of data wrangling. It could also be that we might decide to perform some data aspects in relation to some data analysis aspects in relation to creation of descriptive analysis reports. So it could be that we might want to even to create a summary table that would allow us to be able to answer a research problem. We could also decide to filter for records with keeping in mind a certain condition to ensure that we narrow down to the subset of data that we want. We might also end up, doing just data analysis for the purpose of just summarizing key insights about the data set that we have. So doing a bit of some calculations in relation to descriptive statistics. We could also end up deciding to do data visualization tasks, such as creating histograms, box plots, scatter plots, and bar charts. And last, we could just all collectively, once we have done our data analysis tasks, we could organize it in a way that it looks more presentable to an audience. That could be maybe a business stakeholder, or even just a data stakeholder that would find the key findings from the data set that is in consideration useful. So to start us off, we are going to cover those particular aspects. At this particular point in time, I would want you to go through now the actual practice work that we had, not the practice work, but the reading that we've shared. So just go through that, and that should take you about 10 to 15 minutes. Just go through that and then go through this quiz. It's a self-graded quiz. Once you've gone through that, then come back, then we'll continue into our practice bit. If you're not an Afterwork member, you could skip that and come to the next section where we can continue from. That is with regards to the practice work that we are going to be covering. All right, so you can pause the video and then we will resume in a bit. All right, so once you have gone through now the reading and the quiz and you're good to go, you should have a firm understanding of what data analysis entails. The next thing that we're going to be doing is to go through this notebook, which is just a document that contains the concepts that we'll cover in relation to data analysis. So we'll cover data exploration, selecting columns, ranking, performing ranking or sorting, using aggregate functions, as well as using grouping or group by and pivot tables in order to create summary tables. So these are the concepts on the far left that we are going to be going through. And the approach that we are going to use is going through the examples and then working on those particular challenges in relation to those examples. So using the key lessons from the examples to work on the challenges. Now, once you have opened this notebook, it's a practice notebook or practice resource, the first thing that you need to do is to go to File, then go to Save a Copy in Drive, and this should ensure that it will ensure that you have your own copy of this notebook that you can be able to make changes to and even save it for further use maybe later onwards. So click on that, and this should open a new tab that you can be able to use. I won't click on mine because I already have this one. This is a master copy, but I'll just open mine in playground mode. That way I don't have to make any changes with regards to that. So starting off, once you have made a copy or saved a copy in Drive, save a copy in Drive, go to the next tab, the one that has opened, and now you're going to use that. You can rename it the way you want by changing the name at the very top, and then we will connect our notebook to Google servers, because this environment that we are using is provided by Google, and these notebooks are saved in Google Drive. So notebook is just generally a document that data analysts and data scientists use for performing data analysis work. So in this notebook, we have code cells and text cells. Inside the code cells, we will have just our code. Inside the text cells, we just have content that will just help us be able to achieve the learning objectives. So starting off, we are going to go to the prerequisites section. So click on this arrow to expand and import the pandas library as well as the NumPy library. Don't worry about that prompt, that pop-up that came up. It may not show up in your side if you've saved a copy in Drive, but if you haven't, it will show up in your screen. So import the pandas and NumPy libraries. These are two libraries that will be essential in helping us perform data analysis tasks. So pandas is a library that we can use for data manipulation, and NumPy is a library, Python library, that we can use to perform scientific computations. Again, libraries, they're just chunks of code that have been written for performing specific tasks, like for manipulation and for scientific computations. All right, the first concept is data exploration. So expanding that, you can either click on here or just at the center, but don't click on this icon, just at the center. So let's load this data set. It's the data set from, it has Ebola cases. So we're going to load it from this URL. So we use PD, which is pandas here, PD .read CSV to be able to read that particular file, and we can be able to do that as shown. Copy this and put it inside the read CSV function, and we store this data, this table that we store what we have on this right hand side inside Ebola DF, and then we preview the first 10 records, as you can see, by using the head function. So you can decide the first 5. If it's the first 5, you can even just leave it. By default, head will just give us the first 5, but if we put any number that we want, we'll get the first 5 or 10 or 20 records that you want. You can just define the number here. So if it's 20, you just put 20 there. And running that first 10 records, we can see. So you can see we have this data set. We have country, month, year, latitude, longitude, value. And we can see there is some missing values. These are records, they're Guinea records, etc. If you want to have a look at this approach just helps us to just understand the structure of the data set, which we have. If you want to check the last 10 records of the data set, we can do that using the tail function. So run that and have pass 10 inside the parentheses, and you can see that we have 10 records in that regard. Okay, so moving on, so this gives us an idea. We have like 30 records actually within the entire data set, because we start from index 0. This is not really a column by itself, but columns are country, month, year, longitude, and value. This is just an index column we just use to assign to records to just know how many they are, or just identify from the other records. So we can see we have 31, yes, 31 records. It starts from index 0. Taking a sample, so if you want a representative sample of the entire data set, so that we have also have a good and fair understanding of the data set, we can do this. You can see there's a data set with missing values for that. All right, so work on the challenges in this section, and then once you're done, then we can continue. All right, selecting columns. So sometimes we might want to select a particular column, the values of a column, and perform some operation on that particular column. So so assuming like this particular data set, we only wanted to work with a value column. This is how we would do it. We just define Ebola DF. So Ebola DF is the table that we had here. Where is it? Here. By the way, in these other cases where we are storing, so we're actually getting the 10 records, like in our case here, we're getting the last 10 records and then storing them in this variable, last Ebola DF. That's what we're displaying. So the same case here, we might want to get only those records or those values in the value column. So we then later we store them in this particular variable and preview the first 5. So we use a double square brackets when we are specifying the record. So the values of that column. So you can see here in 122 to 24. So if we go to heading first, we can see head at the first record, 10 records, 122 to 24, which is what we see here. Sometimes we might want to select again multiple columns, and at the same time even preview the last 10 records. So this is how we can be able to do that. So we just like here, instead of just saying one column, we can put a comma, then we define another column, but we of course have to ensure that the name here is as exact as it is on the table. Otherwise you won't be able to retrieve that particular column. So you have to ensure you do that. So comma, then if the other column name is Lon, L-O-N, just for ease of understanding, that's how we can be able to implement it. But yeah, let me just remove that and go back to what we had. You can also, to run the cell, you can just use also Shift Enter as a shortcut. You don't also have to do that. All right, so continuing, moving on to the next bit. So sometimes we might, as mentioned, this is actually this is the same step that we had done there, but we're selecting multiple columns like what I had demonstrated, but now we can preview the last 10 records of those columns as shown here. Alternatively, we can use what is called the iLock approach, or iLock method, where we are able to select the we can use what are called indices to be able to select the columns that we want. So for instance, in our case over here, we can decide to select the first 2 columns that we want. So let's first of all have a look at the first, country latitude, which you can see here, country latitude. Let me see, country and latitude, which we had defined here, country and latitude. And then we can also decide to use another way using the iLock method. So we can decide to use what are called indices. So we start, indices are like numbers that you, or positions that you assign to that have been already, so positions that we can use for each and every column. So those positions have already been assigned. So we can say this is actually position 0, 1, 2, 3. So we can use position 0 and 3 to be able to define the columns that we want to retrieve, as you can see here. The reason why we use 2 square brackets over here, it's because we are doing multiple selection. Sometimes you can just choose one and you should be able to see country appearing, but now we have multiple of them, so just leave it as that. The other bit, sometimes we might want to select, actually, here we are selecting columns which are separately, like, they're far from each other. So we have country and we also have latitude. If we want to select possibly, if we wanted to select the ones that are the ones that are next to each other, let's say country and month, we can also do that. Only that in our situation over here we are using just a comma, but we might not use a comma. We might decide not to actually specify using this particular approach. We can still, instead of using square brackets, instead what we would do, we would say from index 0 to index 1. So the second one usually doesn't count. So we select columns from position 0 up to, but not including position 2. So if you want to select, for instance, the columns country and month, you would need to have an idea of the position for country and the position for year. You don't necessarily need to know about this one, but you only need to know much more that about this one. So you would select the position for the records with country, as well as you would actually define in your selection what we have here, 0, the country index position, as well, not, yeah, country position, as well as the item, the position year, which is the item just after, the position of the item after, or the column after what you want to select. I think this usually just comes in with just a lot of practice, but you can also experiment, and we store the outcome of that in this variable, and we print the first 5 records of that particular. It's called a data frame. So that data frame, work on the challenges, and then we come back and we'll continue. All right. The next thing that we're going to do is to select columns. Again, the first concept was just a bit more straightforward. We can be able to select specific columns, not just one, or you can also do multiple of them and also perform data exploration on those columns. But sometimes we might want to determine the unique values within a particular column, and we can do that through the use of the unique function. So this is how, again, by the way, initially I had shown you this method. So there are multiple ways of selecting a column. So this is one method, by the way. A second method, let me just create another code cell. A second method would actually be to remove this in a bracket. So let me just do this. You can also do this. This is the other method that we can use, value, but it may not necessarily give you the table that you want in this format. We can also use this method without the second brackets, or we could also use a dot value to also, get the records. So that's also another, but this usually becomes a bit tricky when you have column names with multiple words. So yeah. But yeah, let's just go back to this particular use case. So if you wanted to get the unique values from a column, we can use this method. So we say Ebola DF, which is the data frame, the original one. And then we specify the column that we want, and then we use the unique function to be able to specify the unique values and store the outcome in Ebola countries. And we can now be able to put those values inside what is called a list in Python. What you can do, what you can see here, these are the columns, unique columns in this particular country, because the country has multiple values which are repeated. And you can answer this, this can help you answer in terms of, if this data set is the only data set that was used to collect information about Ebola, then you might say that you can conclude that the countries that had issues with regards to Ebola were these countries. And by the way, we are not using this data set to stereotype or to do anything. This is just a data set that is meant to help us just understand what's happening. No harm intended when we mention some of the countries here. These are some really good countries to visit nonetheless. So The next thing that we need to do is to select rows with columns with certain values. So assuming that you have, let's say, this row, where is it? Where is it? So this is the data set that we have. Assuming that you only wanted to select only rows for maybe Sierra Leone or a particular country, then we can do that using the isin function. So this is what you can see, the isin function. Again, here we have defined the country column using the second method that I'd shown you, where you use a dot instead. So Ebola, then square brackets, then Ebola DF dot country. Then we check whether Liberia, the text Liberia, is actually found within that particular that particular column. And the records, actually, this actually retrieves the records for from that particular data frame, Ebola DF, which have this particular text in the country column. And we store that and we preview that, those particular records. If we wanted to get now the opposite, like, those other countries, not the ones that have Liberia, but those other ones, it's usually not a difficult task. The task is usually just to put a tiled sign. It's usually this character. This is usually called a tiled character. On your keyboard, it's usually shift, and the button that you normally use is the one right next to 1 on the left side of your keyboard. Or when you have on your keyboard, there's the button, there's 1, 2, 3. But beside 1 on the left hand side, there's a button there. So if you press shift and enter, you should be able to get the tiled. So tiled will give us those other records which do not have this Liberia value for the country column. So that's what actually we do here. We use the tiled, and then we select the sample of the records, the other countries. So Liberia is not actually in these other records. All right, that's it. Work on the challenges, and then we'll continue. By the way, just verify from the solution notebook. Then we'll continue to the next section. All right, so once we have done that, the next concept that we're going to learn is sorting. Sometimes we might want to display, say, this particular data set, the outcome data set, sorted by maybe year or a longitude or latitude, or sorted even by value. Maybe you wanted to determine the top cases or the bottom, the lowest cases. This particular operation usually comes in handy. Yeah, so assuming that we were working with this data set, you see the way we wrote this particular piece of code here. We could decide to now perform sorting by simply adding some code at the very end of this statement. So in our case, it's still the same code that we're using as before, but now we might decide to add sort values function to be able to define how we want to sort. So, and we say we want to sort by the value column by, just helps us to match the column that we want. And then we want to ascend in ascending order. So normally ascending order, you would set this as 1. If it's descending, it's usually 0. You set this as 0. So the output that we want to see, so we can see that these are our records, but they're sorted in ascending order. So the value over here is greater than these other ones. All right, the next thing that we are going to do is to be able to rank. So sometimes, yes, this is sorting, and you can actually experiment also by changing some of the values for the arguments over here. But now, sometimes you might want to rank, like, to introduce maybe some other column and be able to rank each and every, let's say this is rank 1, 2, 3, 4, to be able to introduce maybe some sort of rank. We can be able to use what is called the rank function to be able to rank the records in maybe ascending order based on a certain column. So for instance, we can calculate the rank of values in the value column, and then be able to sort in descending order from highest to lowest. And let's see that. Let's see how that happens. Like you can see in our situation over here, still we have the original data frame that we were using, Ebola DF, but the only thing is that we are introducing some ranking based on the value column. Like this particular record, if we were to rank it of all the records, where would it be positioned at? Like, this would be ranked as the 13th record in that particular data frame. All right, work on the challenges and then we'll continue from there. All right, so once you have verified the challenges, the next step is to go through aggregate functions. So aggregate functions they help us summarize data. So sometimes you might want to find possibly the minimum, maximum, average, sum. So those are the aggregate functions that would come in handy in certain cases. So, but before we do that, let's first of all determine how many records we have in our data set. And we do that using the shape property, which you see here. So run that. And we can see this is in Python, it's usually in Python, normally, well, specifically in pandas, this is just what is called a tuple. But the first thing that we see here are 9 records, and these are columns. So in any case, when you use the shape property, we apply it to the data frame that we want. So in our case over here, we want to get the Liberia records. We can be able to do that using the shape method, and which will give us the columns that we want as well as the number of records. So that's just something I wanted to introduce, but later let's see how we can also work with just different types of aggregate functions. So starting off, count allows us to be able to count how many records. So this was just one of the ways of counting the records, but we can use an aggregate function for that. Instead of using the shape property, we can decide to count how many, and we should get a number of how many records or values we have for that particular column. So for instance, you can see here for country column, we have 9 values, year 9999, which generally would equal to about just 9 records for each. But again, if you have maybe 8888 and 9 somewhere, that means one of the records, you have still 9 records because you have a column that has missing values for others. Like for example, there's some missing values here for some records, for some 3 records, because 9 minus 6 is 3 for that particular use case. Okay, so sometimes you might also want to check for any sort of duplicates. To be able to check for duplicates, we can do that. First of all, just remove the shape property, which we are aware of. We can do that by using this method where we have Ebola DF, we reference the data frame, and then we use Ebola df.duplicated to be able to retrieve those duplicate records. But we want to know how many records there were. But generally, when we retrieved, we did not find any records. So it means we didn't. But you can still use the shape property to determine how many records and values, or how many records there were, which in our use case, in our case, we don't have 0. In some other situation, we might want to perform some aggregate, like, perform sum, like addition. So if you wanted to find, say, how many, you wanted to find the sum of the values column for the records with Sierra Leone, this is how we are able to do that. So again, we retrieve the Sierra Leone records, and then we also want the values column for that. So if I am to remove this, just for ease of understanding, this is what I would get. I would get the values for Sierra Leone in our situation. These are just for Sierra Leone, as mentioned. This is a different approach that we've introduced, but you can always change the country. Liberia, you get all the values for Liberia only. But now we want to perform a sum of everything, including the missing values, but missing values will just be treated as 0. So we won't be able to have any sort of, they will be treated as 0, no records. So the sum we'll get as 3,978. Like, this would be the answer that would provide how many Ebola cases in Sierra Leone were reported given that Ebola data set. Sometimes you might want to compute the minimum value for each column in some use cases. But again, you can also do the same thing in certain cases, like, wanting to determine the minimum value for the Ebola cases and also the maximum value. But this is how you can be able to determine the minimum and the maximum values. This may not necessarily be of huge importance when it comes to answering a business question, but it still helps to understand how we can use the minimum function. We just apply it to the entire data frame, but again, you can also apply it to a specific column that you want. It could be, let's say, value for all the records that we have, and you see that value, there's one which is the minimum, but you could also change to max if you want. The maximum number of cases that were reported were that in one of those records. Okay, so moving on, maximum, I think max is actually what we have demonstrated. So we can also be able to do that. Unfortunately, this does not answer this question, which record had the highest number of cases. Actually it does. This actually, yes, this particular record. And yes, this actually also, this one did also do that. So just for understanding, this record, what we used when we applied this, we got the record that had the minimum number of cases, Ebola cases. For this, we had the record that had the highest number of Ebola cases. Yeah. So, and you can see that, yeah, let's see. All right, mean over here, it's actually it's also another aggregate function that we can use to find the mean value for the mean value for the values in Sierra Leone. So that is something that we can do. You can use it just as the sum function. You can also find mode maybe in one particular column. You can see mode of this country is Guinea. Median for one particular column. You can also perform some descriptive statistics to understand just the entire feel of the entire data set. So we could find the count. Let me just run this. So the count, how many, so this is just a descriptive, it's just a statistical description of the entire data set. So we can decide, when we have this, we usually perform an analysis on only the numerical data, numerical columns. So month, year, longitude, latitude, value, as well as ranking. So in our situation here, we have 31, 31, 31. So all this means, like, we have 31 values inside the month column, 31 values inside the year column, 31 values inside latitude, 31 inside longitude, 22 values inside. So it means generally, and also ranking. So it means that we have missing values. We should expect, if our data set didn't have any missing values, then all these should have been equal. But we have some values here which are not equal. So we have about 9 missing records, because 31 minus 22 is like 9. 18, because of there are 2 columns here which are equal to 22. So 18 missing records. But again, we could also find some other statistics. We can also understand our data set better by just having a look at these other statistics. Mean of the values in month column is 8, which is like 8.1. That's, I think, August. We could translate it to August, year, etc. There's standard deviation, there's minimum, 25th percentile, 50th percentile, 75th percentile, and maximum. All right, work on the challenges, and then let's continue from there. All right, so the next thing that we're going to go through is grouping. Sometimes we would want to summarize a table with a shorter table, a smaller table. Maybe if we want to perform data visualization, maybe using a pie chart would require you to have the count of maybe records or count of something, and we can do some sort of, we can understand the proportion of the values that we are working with. So normally, summary tables, which are going to be the things that we're going to be creating now are a summary of a bigger table. So we create summary tables, which are just smaller tables, which are a summary of the bigger tables. And that's what we're going to do in this section in grouping, as well as also in pivot tables. But starting off, we're going to work with another data set, an insurance data set. Let's load it and preview it by using the head function. This is the data set. You can understand it. You can also use sample, whatever, tail, whatever that you want. But we have a good understanding. We have this records, which represents a respondent, some information about the respondent and how much they also spend generally. Yeah. So group by function, assuming we wanted to we wanted to create a summary table that will give us a mean for each region. So we have a region, but we also want to just a mean expenses for each region. So we can do that as shown. So actually not necessarily, it's actually a mean for each and every numeric value. So age, the mean is this for Northeast, West, Southwest, BMI, etc., etc. So we use the group by function, and we specify what we would want to group by in terms of what we are really interested in. We're interested in region, and then a mean is the function that or operation that we want to perform on the entire data set using the region column. So that is what you can see on our data set. It's a summary table of the entire table, and you can do some other visualization, maybe highlight some highest areas, highest values and lowest values, etc. Even use some other visualizations aside from a table. The same case, this is by region. We might also want to group by sex. By sex, it would be by gender. So, and also let me just group that, and you can see how that looks like. So not even fast. Let me just remove that first so that you're able to see. So, okay. So I think that is the best one that we can do now. Yeah, so let's just first of all do that first. So sometimes you might want to get maybe some to get the first records based on. So in our situation over here, we're actually grouping by the sex column, the gender column, sex column. But the idea is we want only the first records for each and every respondent in that particular grouping. So we can group the female records and male records, but we want only the first record and the first record for each and every category. And this is how we are able to achieve that using the first function. But again, we group by the sex category column, as you can see here. So this is the first of those records in each. So even if you are to go here, so the first record in our data set when we ran this, we had female 27, male 33. So we should expect female and male. And if we do last, we are going to get the last records in that grouping, if you want. In some situations, we might want to group by maybe expenses. We might want the expenses column, but now group by maybe gender. So we want, let's say in that summary table, we want gender, maybe male, female, and then we do expenses. But again, we also want the sum expenses, just to understand maybe which particular group based on gender had the highest expenses. So how we achieve that is, first of all, we define the column that we want to perform our aggregate on, which is insurance DF, and then we define our group by function. Inside, we define which column we want to group by, and then we say we use the sum function. So running that, we should be able to see female, male, and we can be able to see the values. You can also put a double for ease of displaying the outcome. Is it going to work? No, it doesn't work. Okay, it's just on one dimension of no. Is it going to work? No, it shouldn't work. It shouldn't work. Just yeah. But yeah, you can just leave it as it is. But yeah, but generally, as you can see, we have now in some of the expenses for female and male. In some other situations, maybe if you want to again preview this in a different way and also use it a different method, a much more cleaner method, which is the second method here, insurance DF, that's the data frame that we are working with. We group by the sex column, and then we set as index to false to ensure that we are not working with having an index. I can actually remove that and you see what happens. And then we define the column where we want to apply our aggregate function to, the aggregate function. So let's uncomment that and comment the first one so that we don't apply any changes to that. So you can see this is what we are getting as our output. But if you want to display this much more cleaner using a table, we can use as index and set it as false. So this is a table that we can even export, but just note that this is actually, I usually prefer the second method over this other method, but all will achieve the same. So assuming we wanted to do a mean of BMI for each region, so northwest, northeast, etc., but we want BMI, the mean of that, we first of all define, using the first method, the column where we want to perform our mean operation, or our mean operation. Then we define our group by, then we set the mean function, as you can see. Using the second method, so just comment that. Using the second method, we use the data frame, group by the region as index as false, we set it BMI, then mean. So if we run this, you should be able to see that in a much more detail. We can also perform, so here we are doing just one particular, each aggregate function. We are actually applying an aggregate function for each, but we can also here decide to do some summary statistics, like what we did before using the descriptive method. Like we did here, this we did for the entire data frame, but we can also apply the same for just a table that we want. Let's say, for instance, we have region expenses, then we want to do some descriptive analysis on that. This is how we are able to do that. So region, then the expenses, so we are applying our descriptive analysis, the describe function to the analysis, to the expenses column, as you can see. So we have count how many expense records that we had for that particular case, the mean for northeast, standard deviation for expenses. Again, all this is for expenses. Group by, we can, okay, well, further we can also do that. We can also group by two columns, not just one column, by another column. So assuming we wanted to have region and we were working with expenses. So assuming we wanted to work with region, and on one side we also wanted to have children. So we wanted to have region, then children, then the sum of those. We can do that as shown here. So we have region as well as children. But again, use the second method if you want. I think it should overwrite the first one. Yes, it should overwrite the first one if you uncheck that one. Okay. All right, so moving on, we might also want to perform multiple aggregate functions after performing some grouping. So you might maybe do grouping of region and expenses, then perform, have a mean as a max and sum of expenses shown together. So this might be what we want. So we have in our situation over here, just a minute. In our situation over here, we have region, then mean, max, sum. altogether, this is how we're able to achieve. We use the aggregate function as opposed to just using the actual sum or respective aggregate function. So we just use the aggregate function, and inside it we have a list, and that list will contain whatever aggregate function that we want. This is the first method. You can also apply that using the second method, which you can see here in the second case. So let's also check that. All right. Moving on, we can again, I think this is actually the same thing. The only thing here is that we, in our situation over here, we only have one column, but we have one column on the left hand side, but we can have multiple columns, but again have a numerical column on the far end. So in our situation, we can have region and gender, and also have expenses also displayed. So we can group by two different columns. So as you can see here, or neatly, let's see. Okay, yes, this is also okay. This is how you can also be able to see northeast female, northwest east male, etc. Lastly, you can, I think this is also another way. We can still, actually, this is the first method that this is the second method that we, this method, the second method that we've been using, that's what we have used here. But you can also use the first method by simply specifying the columns that you want to group by. You specify it inside the group by function, the first one, then the second one, as you can see here. So it should yield the same outcome as before this one, but this one just gives us a good idea of how that is displayed. But again, we can do the same thing, method 2, just a second method. Still, it's actually almost the second method, actually the first method that we had before. Also this of the third one. I think that's it for group by. Work on the challenges, then verify your solutions with the solution notebook, then we'll continue. All right. Moving on to pivot tables. So pivot tables help us also create summary tables. They're more like group by functions, only that with pivot tables, it's usually sometimes a whole lot easier, but sometimes you tend to tell people you need first of all to learn how to work with group by. Then once you have gotten to learn about them, then you can work with pivot tables. And in some instances, you could also come across code that has been written using group by functions. Sometimes one might ask, why am I studying? Why should we go through group by? And yet we can achieve the same thing with pivot tables. But yeah, I mean, you just have to learn a bit more to just understand what happens in whatever situation. So if we wanted to create a table with, let's say, region as well as numerical columns, like the first example, like we did here, we wanted to, where is it? We wanted to do a mean of all the regions for the numerical columns. So we would do the same thing. So pivot table, you use PD, pandas, and pivot table function. We give it the data frame that we want. The index column, which will be on the left hand side, would be region, and then the numerical columns will be on the right. But now we set the aggregate argument to mean, to just say that we want to perform the mean of all the numerical columns in our data set. And this is what we would get. We have age, BMI, children, expenses, region, etc. Much more like what we had here. Here, 39.2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, 39.2. It's actually, the only thing is that in our situation over here, we are using a pivot table, but in our situation over here, we're just using a group by. So you'll note actually the examples are just much more similar, but now implemented using the pivot table. If you wanted to have a table of, on the left-hand side, again, gender, sex, and on the right-hand side, we want to just have values. So in our situation over here, we wanted to just simply have to group by the sex column, but at the same time, we want to get the first records for each. So we can do that as shown. use the pivot table, set the name of the data frame, set the index, and aggregate arguments to second first. All right. If we also wanted to, again, to also have the gender column on the left-hand side and expenses, the mean expenses, we can do the same thing as shown. Still pivot table, set the data frame, set the column we want to group by, and then we have the aggregate function. So the aggregate function in our use case for here might be a bit different. Not the aggregate function argument, which is here, would be a bit different the way we set it. We use a dictionary and we specify the key. The key is going to be the column that we want to apply our aggregate function to, our aggregate method operation to. So we want to do that with mean, and we use the NumPy library to set the mean for that. So expenses and np.mean for expenses. If we want to do the same thing, group by another column, so maybe region and BMI, but BMI mean values, that's how we do the same. It's actually the same thing that we've done earlier. Region, then BMI, the mean of that BMI. Region, again on the left is the index one. Then expenses, we want to perform that on the numerical column for all other numerical columns. So actually for just the expenses column. So we want to perform different aggregate functions using the describe method. So you can do that as shown. So index, then aggregate functions, and you can do that. So I think that's a bit more straightforward, like what we did earlier. Number of children, so region, then number of children. Again, still the same. Not so much, only that we use a sum function at the very end. Sum, the sum value, we set it as a key. There's a value, there's key value. So we have a key and a value pair. So children and the value, that's that. Applying multiple aggregate functions to a group. So we might also want to perform like what we did here, where we had multiple aggregate functions. Like in our situation here, we applied multiple aggregate functions across the expenses column, but of course we had the region as the index. So we can also do the same thing to our column. So where is it here? We inside the key, so key values, it's the same thing. So region sex will be on the left hand side of our table. That's our summary table. But the function that we want to apply to the expenses column would be mean, max, and sum. So this is how we would define. So key value, the key is expenses, the value is mean, max, sum, as shown. And lastly, we can also do the same thing for just multiple columns. So applying multiple aggregate functions. Actually, this is to a group. Okay, I think this is actually easier than this method. So we have region, sex, but we also want to have the expenses and sum of that. So you can see how that has been distributed northeast. We're grouping by region and then by sex, and that's the gender. Then expenses, that's now the sum for that. And you can do even mean, max, whatever. All right, so I think that comes to an end. So just work on the challenges and then verify using the solution notebook, which we have provided here. So for example, for pivot challenges, you should find the notebooks over here, but now, like, something like that, you can be able to apply that. So I think that's just generally it with regards to the practice work. The next thing that once you have finished, you need to do once you have finished the practice work is to go through this project. It's a data analysis project. We've provided a guiding notebook that has just different sections. It takes you through different sections and you can be able to apply the descriptive data analysis steps and also answer the guiding questions that we have provided. We've also provided some code for creating just maybe bar charts that just give you an idea of what you need to do. Don't worry so much about this. There's another course on Matplotlib, which is the language that the library that we use for visualization. You can go through that once you have gone through this workshop. But the idea is that will be in a position to apply some of the methods that we have applied in the other in the workshop today in a real life project. You've performed both different types of of analysis. And if you are stuck, feel free to just research on Google. But again, we also have the solution provided at the very end, so you will find that as well in this notebook. It's if so univariate analysis, etc. Okay, so that's generally it. That's our course so far on what we were meant to have covered. I understand that maybe sometimes it can be a bit more rushed, but the idea is that you are able to cover these learning outcomes. But if you do the projects at the very end, you will feel comfortable enough to even just proceed or work on any sort of data analysis related projects with regards to Python. That's on the descriptive analysis end, but we could also, but that knowledge that you've also gained at the moment should be sufficient enough to be able to undertake further types of analysis like predictive analysis or prescriptive or diagnostic analysis, even going to perform tasks such as hypothesis testing, a bit of that, but those are just other workshops that we can undertake later onwards. If you want to reach out to me if you have any ideas of any courses, by the way, you could always reach out to me at valentine@afterwork.ai. And if you have any questions with regards to the course itself, you can also use the comment section depending on where this particular course has been hosted, whether it's on YouTube or different other platforms. You can also do that. All the best in your learning journey, and hopefully we'll be able to see you in the next workshop, next course, which would be more of data visualization with Matplotlib, and then later data visualization with Seaborn. All the best and see you in the next course.